All right, let's dive right into this explainer and master the river systems of Uttar Pradesh. Whether you're gearing up for a major exam or you just want to really understand the lifeblood of India's most populous state, we're going to break it all down geographically today. We'll trace these massive waters from their icy origins down through the sprawling plains and really unpack their immense ecological and agricultural impact. Let's get to it.
So, here's our game plan for today's exam prep. We'll cover categorizing the UP river systems, explore the mighty Ganga network, look at the Yamuna and its key tributaries, discuss rivers as regional borders, and finally, we'll wrap up with cities, ecology, and conservation.
Okay, kicking things off with Section 1, categorizing upriver systems.
Now, to really grasp how these rivers behave, you have to understand the state's slope. Think of Uttar Pradesh like a slightly tilted table. It slopes down from the northwest toward the southeast, and that topography literally dictates where all the water goes. And based on where these rivers are born, we see a massive contrast. On one side, you have the Himalayan rivers. These guys are perennial, they're snow-fed, meaning they flow continuously all year round. But on the flip side, we have the southern plateau rivers. These are rain-fed and strictly seasonal. Because they rely entirely on the monsoon, they tend to dry up in the summer. And that summer dry spell intensely impacts agriculture, causing some really tough drought conditions down in southern regions like Bundelkhand. When we break it all down, we have our Himalayan giants, like the Ganga and Yamuna, born straight from glaciers, and the southern plateau rivers, like the Chambal and Betwa, flowing upwards to meet them. But hey, grab a pen and pay close attention to this middle category, because it is highly testable. The plains category highlights wild anomalies like the Gomti River. The Gomti doesn't start in a mountain or a rocky plateau. It actually emerges right out of Fulhar Lake, sitting perfectly flat in the plains of Pilibhit. Definitely keep that in mind.
Moving right along to Section 2, the mighty Ganga network, the absolute lifeline of UP. You know, the formation of the Ganga is almost like a geographical math equation. It's built on these prayags or confluences, which you absolutely need to memorize. Notice how the Alaknanda River acts as the constant base here once it forms. It meets the Nandakini at Nandaprayag, the Pindar at Karnaprayag, and the Mandakini at Rudraprayag. Finally, all of this continuous merging culminates down at Devprayag. That is the exact spot where the Alaknanda meets the Bhagirathi and the river is officially born and named the Ganga.
For your exam's spatial mapping, try to visualize tracking this entire journey. It originates at the Gangotri Glacier as the Bhagirathi, and as we just said, officially becomes the Ganga at Devprayag. But here's the crucial part for UP specifically. It enters Uttar Pradesh at the Bijnor district. From there, it acts as this massive, sprawling lifeline, flowing through 27 different districts of Uttar Pradesh, before finally crossing the border and exiting into Bihar. So, what's the grand total? Well, the exact number you need for your notes is 2,525 kilometers. That's the total distance the Ganga travels from its freezing, icy origin in the Himalayas all the way down to its massive delta at the Bay of Bengal. But, we can't just talk about physical geography here. The river acts as a massive civic and economic artery for the whole country. You need to know that a major stretch of it serves as India's primary national waterway, NW1. This stretches from Prayagraj all the way down to Haldia, and it was officially declared as a national waterway way back in 1986. All right, let's switch gears to Section 3, the Yamuna and its key tributaries. The Yamuna system is the Ganga's largest companion. It originates at the Yamunotri Glacier and enters UP at Saharanpur. Quick tip, don't confuse that with the Ganga entering at Bijnor. The Yamuna eventually merges with the Ganga at the famous confluence in Prayagraj. Now, along its journey, it captures some vital right bank tributaries that flow up from the southern plateau, namely the Chambal, Betwa, and Ken rivers. Why do these matter? Because these specific tributaries are absolutely critical for running regional irrigation projects in those otherwise dry, drought-prone southern districts. And speaking of those southern tributaries, there is a specific geographical phenomenon you do not want to forget for the test. The Chambal River is notorious for causing intense gully erosion, which is known in Hindi as Avnalika Apardan. The sheer force of this seasonal water literally carves out deep, dramatic ravines, creating the famous Badlands of the Chamba Valley. It's an incredibly powerful force of nature. Now, shifting to the other side, we have the key left bank tributaries. You'll definitely want to memorize these specific origins and confluence cities because they pop up as test questions all the time. The Ram Ganga meets the Ganga at Kannauj, the plains-born Gomti joins up at Ghazipur, The massive Gogagara meets the Ganga further downstream at Chhapra in Bihar, while the Rapti actually feeds into the Gogharha at Doria. Grouping them mentally like this makes it so much easier to recall.
Let's zoom out a bit for Section 4, Rivers as Regional Borders.
So the really fascinating takeaway here is that these waters don't just idly flow through the land. They actually act as firm, natural regional boundaries between states and even entire countries. For example, the Yamuna heavily defines the western border, separating Haryana and Uttar Pradesh. Up north, the Sharda River forms a clear line separating Nepal from UP's Pilibhit district. And over to the east, the Gandak River draws a natural boundary line straight between Uttar Pradesh and Bihar.
And finally, Section 5, Cities, Ecology, and Conservation.
This right here is basically your high-yield checklist, mapping the state's major urban centers directly to the rivers that sustain them. On the Ganga, Kanpur stands out as the absolute largest city on its banks, sitting alongside ancient cultural hubs like Varanasi and Prayagraj. The Yamuna hosts Mathura, Agra, and of course Delhi. The Gomti sustains the state capital of Lucknow. Ayodhya sits famously on the banks of the Saryu, and Gorakhpur relies entirely on the Rapti.
Now, this next fact is highly testable, and frankly, it's just mind-blowing. Have you ever wondered about the scientific reason behind the Ganga's famous water purity? Well, the water actually contains a unique virus called a bacteriophage. These phages literally hunt down and destroy harmful bacteria, preventing the water from spoiling quickly and giving the river its legendary, almost magical self-purifying properties. How cool is that?
But the environmental importance of these rivers extends way, way beyond Uttar Pradesh. Eventually, the Ganga joins up with the Brahmaputra to form the massive Sundarbans Delta. This continuous, powerful flow of fresh water and silt creates incredibly robust mangrove forests. And this specific riverbank vegetation is absolutely crucial. It acts as nature's very own shock absorber, shielding coastal areas from devastating tsunamis and massive cyclones.
So how are we protecting all of this? Well, tracing our modern civic and ecological awakening reveals a pretty clear timeline. We officially recognized the river's immense economic value in 1986 with National Waterway 1. Then, ecologically, a massive milestone hit in 2009 when the incredibly rare freshwater Gangetic dolphin was officially declared India's national aquatic animal. And more recently, in July 2014, the Namami Gange program was launched to comprehensively tackle pollution and conserve the river's water quality.
These flowing waters have defined Uttar Pradesh for literally millennia. I mean, they've dictated where cities rise, where crops can grow, and exactly where state lines are drawn. Today, we've mapped their icy origins, their complex confluences, and their distinct seasonal behaviors. But as we look at the immense, undeniable pressure they face from pollution and climate change right now, their survival, and honestly ours too, depends entirely on our next moves. Study these facts well, understand how these fragile systems work, and ask yourself, how will our modern conservation efforts ensure these ancient rivers keep flowing? Thanks so much for joining me for this explainer. Keep up the great studying, and I'll see you next time.